All right, so let's talk about 1.2 transformations of functions. After this, we should be able to identify the vertex and axis of symmetry for absolute value functions, as well as quadratic functions. And then we want to be able to graph using transformations. So I have a graph here, so it's going to be helpful if you guys have graph paper. But let's start with the absolute value function. So the absolute value function, f of x equals a times the absolute value of x minus h plus k. So this is what we're dealing with, and it's very similar to, actually I think we can talk about both at the same time. The quadratic function, right? So here it is in vertex form. Well, you remember for the quadratic function, I'm sure, and so hopefully you remember it, and it goes with the same with the absolute value. Our vertex for both of these is h comma k. Now you'll notice that in these equations, it's negative h, so it's always the opposite here. The way that I like to remember that is I always say the x always lies. So like your ex-boyfriend or girlfriend, right? They're always lying. It's the same thing here. So this number in here with the x, this number in here with the x, in the vertex, it's the opposite. So if this was x minus 3, then this would be a positive 3 here. If this was x plus 7, then this would be a negative 7 here. And then the k, not inside with the x, is just the regular k here. So this and this would be the same. So if this was minus 8, this would be minus 8. If this was plus 13, this would be 13. So there's our vertex. Now A will stretch the graph vertically. Okay, and we're going to look at what that means in a little bit. And then, well, I guess H, really it shifts the graph horizontally, right? Because it's in there with the x, so it's affecting our horizontal movements left and right. And then K will shift the graph vertically. So it's outside with the y, so that shifts us up and down. So let's look at this. Let's look at f of x equals, let's start with just the absolute value of x. So with the absolute value of x, notice, right, I could think of this as the absolute value of x minus 0 plus 0, right? Those would be the same thing. Why would I write it like this? So then I have an h and a k here, right? This is the opposite of h, but the opposite of negative 0 is still 0. So my vertex here is 0, 0, right? It would be similar if I put f of x equals x squared, right? If we were looking at this, which I'm going to erase in a second, this would have a vertex of 0, 0 as well. Okay. So let me actually get a darker color here. Let's do this red. So there's our 0, 0. And then it's absolute value. So we can plug things in. If I plugged in 5, I would get 5 out. If I plugged in 10, I would get 10 out. If I plugged in negative 5, I'd get negative 5. And if I plugged in negative 10, I'd get negative 10. Right? And so the absolute value function, it's this v, has a point right there. And it goes on forever. Right? We talked about the domain and range in 1.1. So in this case, the domain is all real numbers, right? Forever to the left, forever to the right. And the range is 0 to infinity, or y is greater than 0. Sorry, greater than or equal to 0. So now, if this is f of x, right, this one right here, if I want to talk about g of x equals the absolute value of x plus 3 minus 4. Well, now what is the vertex? The vertex, so it's the opposite of the inside. So instead of plus 3, it's actually going to be minus 3. And then we have minus 4 there. So the vertex, negative 3, 1, 2, 3, negative 1, 2, 3, 4 is right there. Now, everything else stays the same. So really what we can think about is this is going to shift. So I'm running out of space. We're really shifting. Well, that negative, so this is a plus 3, but we know it's really negative because the x always lies. So that's just left 3 and down, right, because of this, down 4. And the vertex, right, don't you see the vertex goes left 3 and down 4? Well, every single point on this graph goes left 3 and down 4. So this one right here would go left 1, 2, 3 and down 1, 2, 3, 4. It would be right here. This one, it'd go left 1, 2, 3 and down 1, 2, 3, 4. It would be right here. Right? 10, 10 goes left 1, 2, 3 and down 1, 2, 3, 4. It'd be right here. And similarly, this 10, 10, or sorry, negative 10, 10, 1, 2, 3, 1, 2, 3, 4 would end up right here. And so the graph we get now looks just like this. Just like that. So the whole graph shifts to the left 3 and down 4. That's what the transformation does. Let's look at a quadratic. Let's look at, first we'll start with f of x equals x squared. So I'll plot 0, 0. And then if I plug in 1, 1 squared is 1. 2, 2 squared is 4. 3, 3 squared is 9. Oops, right there. And then similarly the other way, negative 1 squared is 1, negative 2 squared is 4, negative 3 squared is 9. Right, and so we get this beautiful parabola. Oh, hopefully yours looks better than mine. So now, right, the vertex here we know is 0, 0. And I just realized I didn't even talk about the axis of symmetry. Remember, the axis of symmetry, which I'm going to denote as AOS, the axis of symmetry cuts the parabola in half. It's that line, x equals, it's always going to be x equals for a regular parabola. It's going to cut the parabola in half. And it's always the same as the vertex. It's always, I'll make a note over here, the axis of symmetry which we're going to call AOS, is x equals h. Right, so it's the same as the vertex. So over here, right, the axis of symmetry for this one was x equals negative 3. Because look, if we drew a line down negative 3 right here, right, maybe I should do a dotted line right here, this cuts that graph in half. Right, it goes right through the vertex, splitting the graph into two identical parts, reflected parts. So now let's graph g of x equals x plus, let's do x minus 5 squared minus 7. Well, now what is the vertex? 5, negative 7, right? The opposite of this one, and then exactly what this one is. And our axis of symmetry is x equals 5, same as the vertex, the x of the vertex. So we're going to take this graph that we have here, move everything to the right 5 units, and then down 7 units. So we know 5, negative 7 is the, oh, let me get a better color. I'll use green. 5, negative 7 is our vertex. Well, if I take this point and move it over 5 and down 7, it goes right there. And this one, over 5, down 7, goes there. This one, over 5, down 7, goes here. And this one, over 5, down 7, goes here. This one, I'll show you this one. 1, 2, 3, 4, 5, over 5, 1, 2, 3, 4, 5, 6, 7. Down 7 goes right there. This one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Right there. And so here is now our parabola. Right? It's moved to the right 5 and down 7. Every single point has moved to the right 5 and down 7. So now let's talk about that A. Right? The A stretches the graph vertically. So let's say I had f of x equals 2 times x minus 3 minus 4. So what I want to do here is I want us to think, okay, we know the parent graph, right? It goes like this. That first one we draw, the absolute value of x, it goes just like that. Okay, now this 2 in front, that 2 is going to vertically stretch. So vertically right up and down. And we know it's up and down because it's not inside with the x, right? This is the inside. It's on the outside with the y. So we're going to vertically stretch by 2. That means everything's going to become twice as far away from y equals 0. So here's what that looks like. Green. This point right here, it's 1 away. We're going to multiply it by 2. It's going to go 2 away. This point right here, it's 4 away, right? 4 away. So if we multiply that by 2, that becomes 8. So we need to go 8 away to a point right there. Right, that, and then we know that it's reflective about the axis of symmetry. So if I go negative 4, 1, 2, 3, 4, I need to be at 8 as well. Right, so our new, and this doesn't change because it's 0 away, and 0 times 2 is 0. So our new graph does that. So right, this is, if we called this the absolute value of x, this right here is 2 times the absolute value of x. It's not the one we're graphing yet. We're not there yet. But we did part of it. We stretched this graph vertically by a factor of 2. If it was negative 2, that would have flipped this graph across the x-axis. Right? So it would be upside down. It would go like this. But it's not negative 2. So let's look at this. On the next one, I'll do a negative. So now we need to shift the graph, right? And how are we going to shift it? Well, the vertex is positive 3, the opposite, comma negative 4. So that means we're going to shift right, because it's a positive 3, right 3 units, and down 4 units. So I'm going to take this green one, not the blue one, right? The green one, and shift that to the right 3 and down 4. So, and I'll use red for that. So I'll start with this one. So 1, 2, 3, 1, 2, 3, 4. And of course it's there at 3, negative 4, because that's what we said our vertex was. But every other point, right, we don't know. So 1, 2, 3, 1, 2, 3, 4 right here. Oops, right there. Let me get rid of that. Now, we know that it's symmetric, so I know that there's going to be a point right here, right? That's this one. Let's look at this one. 1, 2, 3, 1, 2, 3, 4 right here. Right, and that was 4 away. So if I go 4 away this way, I know there's going to be a point right there. Right, because I know it's symmetric about the axis of symmetry. But I can also count this. 1, 2, 3, 1, 2, 3, 4. So this one, and now it's like kind of a mess. So I'll try to make it thicker. This graph looks just like this. There it is. That is our f of x, which is 2 times the absolute value of x minus 3, nope, minus 4. That's how it's done. All right, last problem. Let's look at f of x equals negative 1/2 times x plus 4 squared plus 3. Oh no, I keep using 4 and 3, I don't know why. So let's go plus 1 and plus 6. Okay, so we'll try this. So I'm going to start with the parent graph, which is I guess I'll use blue. Y equals x squared. So I need 1, 1, negative 1, 1, 2, 4, negative 2, 4, and 3, 9, negative 3, 9. So remember, this is just y equals x squared. We should be pretty good at graphing these by now. Y equals x squared. Okay, so now we need to do the stretch. What are we stretching by right here? Stretch by 1/2, but look, there's a negative. That negative is going to reflect about the x-axis. Make a note of that. Whenever we have a negative, we're going to reflect about the x-axis. So everything's going to flip over. So let's do that. Let me start by just flipping everything over. So 0 is going to stay here. This one, instead of being 1 up, it's going to be 1 down. Same thing here. This one, instead of being 4 up, it's going to be 4 down. So right here, and then 9 and 9. So here's this. This is the first part. And this is y equals negative x squared. Notice it's not in parentheses. The x is being squared, and then we have a negative in front. So now 1/2. Now everything is going to become half as far away from the y-axis. So instead of, let me zoom in a bit, instead of this being at 1, we're going to go to 1/2, right? We get half as far away from the y-axis, so everything shrinks. We compress. So the opposite of stretch would be to compress. So we're compressing here. This, instead of being 4 away from 0, will become 2 away. This one, instead of being 9 away, what's half of 9? 4.5. So we're going to be right here. Same thing here. And you can see that results in a wider parabola. So it's a little bit fatter. That's y equals negative, because we already did the flip, 1/2 times x squared. What are we missing? Well, we're missing the vertex, and the transformations are the translations, where we shift. Let's go pink. We're going to shift. Let me write the vertex first. That's what I like to do. So it's the opposite of this, so negative 1 and then 6. So negative 1 means we're going to shift left in the negative direction 1, and then up in the positive direction 6. So negative 1, 6 will put me right here. That makes sense. That's where the vertex is. I'm going from 0, 0, left 1, and up 6. Okay, this one, I have to be careful here because it's at a half. So left 1, and then up 6. 1, 2, 3, 4, 5, 6. And so I know there's one here as well, right? Because the axis of symmetry is right here. All right, this one, we're going to go left 1, up 1, 2, 3, 4, 5, 6 to here, and so that means here as well. And then this one, 1, 1, 2, 3, 4, 5, 6 right here. And so then there's one here as well. And so this graph, and let me make it thicker, looks just like this. So here's our f of x. F of x equals 1/2 times the absolute value of x plus 1 minus 6. Oh, plus 6, there we go. And there it is.